Hi students, welcome back to my channel. In this video we will discuss about some more previous year MCQs in unit 2. A particle of mass m starts from the rest, undergoes uniform acceleration. If the speed acquired in time t is v, the power delivered to the particle is, we know that power p is equal to w divided by t. The rate of change of work is called as power, which is equal to, from work energy theorem we can write half m v final square minus half m v initial divided by t. So we get half m v square. So we get half m v square minus 0, because the initial velocity is 0, so initial kinetic energy also 0, divided by time is t, so we get half m v square by t. Option D is the correct one. The density of a material in CGS system of units is 4 gram per centimeter cube. In a system of units in which unit of length is 10 centimeter and unit of mass is 100 grams, the value of density of material will be. Here we have to convert one system of units into another. From this principle we can write N1 into U1 is equal to N2 into U2. Here is the CGS system in which unit of mass is gram and unit of length is centimeter. And in a new system of unit N2 we can write 100 grams for mass and 10 centimeter for length. And now by writing in CGS system we get 4 gram per centimeter cube, which is equal to N2. In the new system gram is 100 grams and centimeter is 10 centimeter. For centimeter cube we get 1000 centimeter cube. By cancelling we get 10 here, so 4 is equal to N2 by 10, therefore N2 is equal to 40 is the correct option. Option C is the correct one. The dimensions of mu naught epsilon naught whole to the power of minus 1 by 2 are, we know that mu naught is the permeability of free space and epsilon naught is permittivity of free space. They are related to the velocity of light as c is equal to 1 by square root of epsilon naught mu naught, which can be written as epsilon naught mu naught whole to the power of minus 1 by 2. So the dimensions of epsilon naught mu naught whole to the power of 1 by 2 is similar to c, the velocity of light, whose dimensions is L power 1 t power minus 1. So the option B is the correct one. If force F, velocity V and time t are taken as fundamental units, the dimensions of mass are. We know that force is equal to mass into acceleration, which is equal to mass into acceleration can be written as velocity by time, which is equal to F. By separating M, we get F into T divided by V. So, by expressing mass in terms of force, velocity and time, we can write F power 1, V power minus 1, T power 1. So, option D is the correct one. In dimensions of critical velocity Vc of liquid flowing through a tube are expressed as eta power x, rho power y, r power z, where eta is viscosity of liquid, rho is the density of liquid, r is the radius of the tube respectively. Then the values of x, y and z are given by. We know that eta, the coefficient of viscosity, can be written as F by A into dV by dx. Here the dimensional formula for force is m power 1 L power 1 T power minus 2 divided by L square for area, and dV by dx, the dimensional formula is T power minus 1. By simplifying, we get m power 1 L power minus 1 T power minus 1 is the dimensional formula for coefficient of viscosity. For density, rho is equal to m by v, mass per volume. So we get m power 1 divided by L cube, which is equal to m power 1 L power minus 3 T power 0. R is given as radius of the tube. So R dimensional formula is m power 0 L power 1 T power 0. And now by comparing the critical velocity Vc with the dimensions of coefficient of viscosity, eta and density and radius, we get for velocity the dimensions is m power 0 L power 1 T power minus 1, and for coefficient of viscosity m power 1 L power minus 1 T power minus 1 whole to the power of x, into for density m power 1 L power minus 3 T power 0 whole to the power of y, into for radius m power 0 L power 1 T power 0 whole to the power of z. And by simplifying, we get m power x into m power y into m power 0 into L terms L power minus x into L power minus 3y into L power z. And by simplifying t terms, t power minus x, t power 0 and t power 0, which is equal to m power x plus y into L power minus x minus 3y plus z and t power minus x. When the bases are equal, the powers are also equal. Therefore, x plus y is equal to 0. Therefore, x is equal to minus y. Next, t power minus x is equal to t power minus 1. By comparing, we get x is equal to 1. So, y is equal to minus 1. Next, by comparing L term, we get minus x minus 3y plus z is equal to, by comparing L term, we get is equal to 1. Minus x is minus 1, minus 3y is plus 3 plus z is equal to 1. By moving minus 1 plus 3 to right side, we get z is equal to 2 minus 3, which is equal to minus 1. So, x is equal to 1, y is equal to minus 1, and z is equal to minus 1. Option B is the correct one. So, we can choose option B as the correct option.